Well, hello, my dear friends, and welcome. So right now, we are going to meet this NumPy library. Now, of course, some people say NumPy library, some people say NumPy. You're probably going to hear me say both. But to be literal, it is all about Python, right? We're going to use it in Python, so you say hello to NumPy. So what does a library actually mean, and what's it doing in Python? Well, my friends, Python libraries give you some incredible stuff. It's actually no different from pretty much any of the libraries that you might be able to think of or that you even go to in real life. Hopefully you still do. Keep them open. But in any event, you know how you go to a library and you go to check out a book or some other kind of resource, whether it be readable media or playable media. Basically, both of these things, libraries in general, are collection of information resources. So we can all agree on that general definition. Let's further reduce this idea into what Python libraries do. Hey, what do you want? I told you this was going to be an intro. All right, so look. Python libraries offer modules to use while coding. And to replace the metaphor of the book library, we're going to be coding instead of using books. So you can achieve the goal that you're trying to accomplish through these modules. So let's think about it like this. NumPy is a library that allows us to perform large-scale mathematical, scientific calculations efficiently, quickly, and flexibly. So it's considered indispensable, especially for data science studies, and includes related solutions. So going back to the mathematical sense, these possibilities and abilities give the library its name. NumPy is short for numerical Python. So in other words, we could say numerical Python, but we just kind of shorten it. NumPy, NumPy, whatever. Even though its foundations were laid back in 1995 by a group including Python's founder, Guido van Rossum, Travis Oliphant, and his friends, well, put the last point in 2005. And that's when we got introduced to the NumPy library. Now, you might think, yeah, it could be very similar to lists from NumPy data structures. However, I want to note a big difference here. We're going to be storing data that we can actually call less costly, so to speak, in the variables that we will create with NumPy. And we will also be able to perform vectorial operations with this data. Okay, so what does that mean then? Data that we can call less costly. Well, I do want to elaborate on this a little bit. By way of an example, very clever. Let's just say that we're holding data in a variable, and we'll let this data be in a list data structure, for example, and there are 5 integer values within it. So now when we keep this data in the list structure, well, that's going to support the type of each element in it separately as information. So you see, even if each value here is the same, even if it's all integer, it's still going to have to grab this information and pull it into the list memory. You see, so that's why it's a bit more costly than using NumPy. So here, NumPy reveals its difference, okay? So what is NumPy actually doing? Well, you see, it keeps the same integer values, but then it says, hey, wait, there's no difference between any of these here for me. So I don't need to keep the type of information of all of them in my mind, memory, whatever the metaphor would be, right? They're actually all the same for me. So that's why I'm just going to force all the data that I have to keep, boom, into the same type. And hey, if you really want to, you could also operate separately on the data. But you see how separating like this is going to be a less costly job for resources. All right, so where's this going to actually work for you? It's going to increase the performance and speed of the transactions that we'll do together. Yeah, so my friends, that's just one of the many differences. Another difference is that we can, of course, do vectorial operations with NumPy. As you may know, we can perform operations that we want just by using the variety of capabilities, such as loops and conditional expressions, already with Python, right? But with NumPy, we can fulfill our requests with a couple of lines of code without the need for any of these. So you'll see what I'm talking about when we start some of our practices, and you're going to definitely get a clearer understanding. So right now, let's just talk about what we're going to do with NumPy in general. So NumPy, mainly used in data mining, machine learning, data analysis, and computational structures containing single as well as multidimensional mathematical arrays. So we call these arrays NumPy arrays. And yeah, we're going to definitely benefit from some of the advantages that NumPy offers using these structures with our interfaces. Okay, so that's enough for all this. That's a brief introduction, and we're going to get to working with it in detail. So I want to see you around next lesson. All right?